design concepts. So what is design? Why we need to do design? So as an engineer, you will need to select the appropriate materials, shapes, and load carrying system or structures so that the design structure safely carries the applied load and remains stable and usable during its service life. Okay, so you can see that I highlighted 3 items. The first thing can be called safety, and the second, usable, can be called usability, and the service life can be called durability. Okay, we mentioned these 3 targets of design in lecture 1. Right? So they are safety, serviceability or usability, and durability. Okay. Here I have provided several links guiding you to YouTube videos and articles showing you examples of bad safety design, bad serviceability design, and bad durability design. Okay. Make your own time to watch the videos and read the article so that you can understand better these 3 concepts. Here in this chapter, we'll only talk about one of these 3 criteria. That is the safety or strength criteria. Okay, this is one of the 3 criteria only. Okay, the strength requirement, which is generally satisfied by keeping the stress level in the structural members below the yield stress of the material. Okay, this can be summarized by this: stress, the real stress, is lower than the yield stress. However, in the real structures, there are a lot of uncertainties in evaluating load and strength values. For example, the true loads used, the loads used in design are generally estimated, and they may be substantially lower than the actual loads and the actual service loads. And the strength of elements is not deterministic. Okay, they're just the strengths of materials are just obtained through testing. You can test 100 material samples, and then get an average value and the variation. But in the true case, in field, the strength can also go beyond or go below this range you tested in lab. Okay, this will make you a lot of uncertainties. So normally, we will just use a factor of safety to address those uncertainties. Hope you still remember when we introduced ductile and brittle materials. I said that okay, when you have a stress strain curve, right? Proportional limit to here, and then just a kind of deformation, strain hardening or not. Right. I said that in mechanics materials and in structural analysis, we allow the materials to work within this proportional limit. Okay, they are not allowed to go beyond this proportional limit or go beyond of the yield stress. Okay, and to be safe, we normally limit the stress to some kind of here. So in this way, we actually used a kind of factor of safety to lower this allowable level of stress. Okay, we're not allowing the stress in the design structure go beyond such a limit. It's much lower than the yield strength, than the yield stress. Okay, so this margin is called safety margin, and we control this using a factor of safety. So this factor of safety is just used in defining the allowable stress. Okay, the allowable stress is lower than the yield stress. It equals the yield stress divided by factor of safety. Okay, as shown here. Allowable stress equals yield stress over factor of safety. Of course, the factor of safety is larger than 1. Okay, it's larger than 1. The higher the factor of safety means higher safety margin. But you can imagine that in this case, you will need to use more materials, meaning that the initial cost will be higher. Okay, the typical values of factor of safety depend on the type of loading and the material used in the structural design, and also the importance of the structure. Okay, and will the will the owner want to invest more money to make the structure safe, etc. Depending on a lot of factors. Although the typical factor of safety for structures for steel structures is 1.67. This is a very small, actually a very small factor of safety, because steel is a kind of a relatively reliable material. Well, if you are dealing with soil, normally this factor of safety is larger, like a 2 to 3. Right? If you are designing a wood structure, it could be even higher, right? Up to 5 or even higher. Right? It's, typical problems regarding this design and factor of safety will include with a given factor of safety and allowable stress, determine the minimum strength, yield stress of the material that is needed. Right? This give you this allowable stress and factor of safety, let you to select a material. This is the nature of this first type of problems. Second type would be with a given factor of safety and a material strength. Okay, in this case, the material has been determined. Then determine the allowable stress level. Okay. In the third type of problems, you may also be requested to determine the factor of safety in an existing structure. Give you the strengths and give you the loading conditions so that you can calculate the stress in it. Then you can estimate the factor of safety in the existing structure. Okay. So let's look at this first example. It's just regarding the direct calculation of a factor of safety in an existing structure. Okay, here we have a connector, right, to determine the factor of safety with applied load 575 kilonewton, that is the P. Right, the 6 bolts are in single shear connection that have an ultimate strength. Right here, this is a shear strength, right? Shear strength. This also, you can consider that this is the yield stress in shear, right? That is 670 MPa, and the diameter of each bolt is 28 millimeter. Okay, so here, as we said previously, to solve this kind of problems, like we're just calculating the factor of safety, you just need to determine the failure stress, or the yield stress, or the strength. They're the same thing, right? Just make it divided by the actual stress level. Right? In this first example, we're dealing with shear failure and the shear actual stress. Okay, actual shear stress. So here, yes, as the first step, we just need to calculate the actual stress, actual shear stress in this bolts, right? So this can be simplified into a problem in our first chapter. Right, so first of all, the force transferred by the bolts will be the force transferred by the bolts is the shear force will be equal to this P, right? This overall load P will be transmitted to the support through the 6 bolts. Right, so this will be 575 kilonewton. Then how about area? And it's said that this is a single shear connection. Single shear connection. Right? Single shear connections only have one section, one plane of each bolt to carry this shear force. Right? So this is A would be pi over 4 times d square, but you have 6 bolts, right? Just time it by 6. Okay, here would be 6 times pi over 4 times 28 square. This would be 3,700 square millimeter. Then the shear stress, the shear stress, this is the actual shear stress, right? That can be calculated from V over A, 575 kilonewton, right, times 1,000. This will be Newton over 3,700 square millimeter, right? So what is this? MPa, right? So you can get MPa directly. This will be 155.5 MPa. And then finally, the factor of safety can be calculated from the strength, 670 over 155.5. That would be 4.31. Okay, so this is our factor of safety.